This is the formula for a confidence interval for proportion. Now, I know that probably doesn't mean anything to you just yet, but a confidence interval is just a way of capturing a range of values for a certain percentage. Whether that percentage is the number of people who are, or the percent of people who are voting in the next election, the percent of people who have Alzheimer's, or the percent of M&Ms in a bag that are red. We use this formula to construct an interval that says, we probably suspect the true proportion, that is the true percentage of, say, M&Ms in a bag, are between these two numbers. This formula is kind of a mess and it looks scary and daunting for right now, but for the purposes of this quiz, we need to use this rewriting of it. So for the first part of this video, I'm going to show you how this allows us to find this formula. So here's what we're going to do. This is called our margin of error. So I'm going to call it mo, which is what this is over here, mo. Now I'm going to set z star times the square root of p hat times 1 minus p hat all over n equal to mo. And I'm going to show you how I derive this formula in green from this formula in blue. I'm going to start by using an algebra trick you probably don't remember, or I wouldn't blame you if you don't know it or are afraid to do it because algebra can be scary. But I'm just splitting this square root. So I can take the square root of p hat times 1 minus p hat divided by n, and the square root of n can get his own set of parentheses. Now I'm going to multiply both sides by square root of n. This guy's going to swap places with the mo. So square root of n multiplies over and mo divides into the denominator. So I have z star equals square root of p hat times 1 minus p hat divided by mo equals the square root of n. And if I square both sides of this equation, I get that equation. So this is the formula that we're going to use in just a minute to get our answer to this quiz. So what is, now you might be wondering, what is z star, what are p hat, what are n, and what are mo? Let's write those things down. So z star is a value that's associated for the level of confidence that we want when we construct our interval. So we might want to be 90% confident or 95% confident or 99% confident that the true proportion is within the range of the interval that we set up. That z star value can be found either in a table or using a calculator. So z star is inverse norm 1 minus CL over 2. In this case, our confidence level, we want to be 95% sure. So if I were to draw a bell curve, what that looks like is we want to be 95% confident or 95% sure that the true proportion is somewhere in this interval. Of course, that means there's 5% total in the tails, or 2.5% here and 2.5% here, or as a decimal, 0.025. So we can find that value in a table using inverse norm, or sorry, rather, we find that value in a table, or we can find it using inverse norm. Inverse norm is very convenient. If you happen to have a TI-83 or 84, just compute inverse norm of 1 minus, in this case, our confidence level for this particular problem is 95%. So we'll say CL is 0.95, plug that into our calculator, and this will spit out a value of 1.96. For different values of confidence, z star will be different. It just depends on the level of confidence you want for your interval. P hat is the percent of people who are in our sample have said a certain yes or no, or are red or not red M&Ms in our case. So actually, in the case of the quiz, it's people who think they believe global warming is a hoax or something like that. So either way, it's just some percent of people who said yes or no. In this case, we don't know. We weren't told that a certain percent of people said yes or no. So when this happens, you have to assume p hat is 0.5. If you aren't told something about the original percentage, like perhaps that we suspect that the sample will produce results that are somewhere around the 40% or 60% or whatever range, then you'll use that value of p hat that they give you. But in this case, we didn't get a value of p hat, so we use 0.5. We're also lastly told that we want to find the smallest sample size to guarantee our margin of error is no bigger than 0.03. So here our margin of error, I'm writing the word mo like it's a name, mo, our margin of error needs to be, we want it to be no more than 0.03. And lastly, we're trying to find the smallest sample size that accomplishes that. That's this guy. That's your sample size. So all I need to do is plug this number here, this number here, and this number here, and crunch the numbers. If I do that, I end up with n equals 1067.111 or something like that. But remember, n is a sample size, so it doesn't really make any sense for n to be a fraction of a number. You can't sample 1067.1 people. It's not possible to do that. So we always round this number up. We always round this number up to 1068, and that is your answer.